These are the three fundamentals you need to comprehend about in-series circuits: current, resistance, voltage, current. In a series circuit, the amount of current flowing through each component is the same. Resistance: the sum of the individual resistances in any series circuit determines the circuit's overall resistance. Voltage: the total of the individual voltage drops in a series circuit represents the supply voltage. First principle: in a series circuit, the amount of current flowing through each component is the same. This is thus because a series circuit only has one path for current to move along. How to apply Ohm's law to series circuits? Ohm's law has a critical proviso in that all variables, voltage, current, resistance, and power, must be related to one another in terms of the same two circuit points. A simple, single resistor circuit using Ohm's law. Any quantity could be calculated with a single battery and resistor circuit because they all apply to the same two locations in the circuit. We can say that point A is electrically common to point B, and that point C is electrically common to point D because points A and B are connected by the same cable of low resistance, as are points C and D. Since point B is connected to both point A and point D, and point C is connected to both point B and point D, we know that there are 9 volts of electromotive force between points A and D, straight across the battery, directly across the resistor. Making use of Ohm's law in circuits with several resistors, we must be cautious when applying Ohm's law to circuits with several resistors. The electromotive force that is causing the current to flow through the series combination of R1, R2, and R3 in the 3-resistor example circuit below is known to be 9 volts between points 1 and 4. However, since we don't know how much voltage is across any one of those resistors specifically, we can't divide the value of 9 volts by 3K, 10K, or 5K to try to determine a current number. The 9 volts value represents the total amount for the entire circuit, but the 3K, 10K, and 5K figures represent the individual amounts for each resistor. The result would not precisely relate to any number in the actual circuit if we were to insert a value for total voltage and a figure for individual resistance into an Ohm's law equation. Given R1's resistance of 3K, Ohm's law will, for R1, connect the amount of voltage across R1 with the current through R1. However, since neither the voltage across R1 nor the current flowing through R1 are known, we only know the overall voltage supplied by the battery across the 3-resistor series configuration. Neither of the two formulas can be used to perform any computations. The same is true for R2 and R3. We can only use the Ohm's law equations if all terms accurately represent the quantities between the same two circuit points. Making use of Ohm's law in circuits with several resistors. The second principle of series circuits is brought up by this: any series circuit has a total resistance that is the same as the sum of its component resistances. This should be obvious. The more resistors that must be connected in series, the harder it will be for the current to flow. A 3K, 10K, and 5K resistor were connected in series to create a total resistance of 18K in the example problem. In essence, we have determined the total resistance represented by R1, R2, and R3. Knowing this, we could redisplay the circuit and represent the series combination of R1, R2, and R3 with a single equivalent resistor. Ohm's law calculation of circuit current. Now that we have the voltage between points A and D, 9 volts, and the resistance between points A and D, 18K, we have all the data we need to calculate the circuit current. Ohm's law calculation of component voltages. Now that we know that current flows equally through all the components of a series circuit, and we just discovered the current via the battery. If we use Ohm's law correctly, we can use it to calculate the voltage drop across each one. Pay attention to the voltage dips across each resistor and how the total voltage drops. 1.5 plus 5 plus 2.5 equals the battery supply voltage of 9 volts. The third rule of series circuits is as follows. In a series circuit, the supply voltage is the total of all voltage decreases. Remember, in a series circuit, each component receives the same amount of current. I total equals I1 equals I2 equals. In the sum of the various resistances in a series circuit determines the overall resistance. R total equals R1 plus R2 plus. Rn, the sum of the individual voltage drops in a series circuit equals the total voltage. E total equals E1 plus E2 plus.